Hello students, a very good afternoon to all of you. So, I am Deepika Davashmita Panda. I welcome you all to the class of Electrical Energy Conversion 2. So, the first chapter of Energy Conversion 2 is your 3-phase induction motor, phase same electrical engineering. So, here are the contents. Introduction, types of 3-phase induction motor we will be studying. Next is your basic principle, parts of 3-phase induction motor. These all are the topic we will be discussing about. So first of all, come to introduction. We know electrical machines are the electromechanical energy conversion devices. We have studied earlier in Energy Conversion 1, that is the EC1, there were all the DC machines, students. And now in Energy Conversion 2, that is EC2, we will be dealing with all the AC machines. So, the construction of AC machines or DC machines is almost the same, only the difference will be connections, supplies and working principle, and obviously in the field of applications. So, what do we mean by energy conversion? First of all, let us discuss. As you know already, conversion means to change, convert things is known as conversion. So, here energy is getting converted from one form to another form, right? So, here either electrical energy to mechanical or mechanical energy to electrical we will be studying about. Let me give you few examples of energy conversion devices. Those are your motors, generators, and we know in case of your motors, what is the output here? Mechanical energy, and it receives electrical energy. So, electrical motors converts electrical energy to mechanical energy. And let me remember you the generators. In case of your generators, we supply or we give mechanical input to the generator and it produces, it generates electrical output. So, always remember generator generates electricity, motor gives you mechanical output. So, now most of the industrial loads are inductive, we know, especially the 3-phase induction motor widely used in industrial applications for continuous operation. And let me tell you, the 3-phase induction motors are of self-starting type machines. What do you mean by self-starting? We will be discussing in the working principle. So, as I have already told you, here we will be discussing about all the AC machines, AC motors. Generally, the types of AC motors are single-phase induction motor, 3-phase induction motor, and chapter 1 is consist of 3-phase induction motor. See, this is the outer, the external view or image of 3-phase induction motor. You can see this is the shaft, see, this is the shaft, this is the knob which will help us to carry the machines, and this is the non-drive part which is fixed with the base foundation using nuts and bolts. Now see, This is the image of rotor winding and stator winding of a three-phase induction motor. And here, this is the stator winding, this is the rotor winding. See, this is the shaft, this is the rotor winding mounted over the shaft. Here is the non-drive part of the machine. This whole is the stator winding, or we can say this is the field winding, this setup is the armature winding, and this is the terminal box. The output terminals are connected here so that any external electrical connection can be made using this terminal points. So, see students, this is the cut view of three-phase induction motor. You can see clearly all the parts here. This is the shaft, this is the total shaft, and over the shaft the rotor is mounted. Rotor is nothing but the rotor winding, okay, which is also known as the armature part of the machine. This is the stator, which is consists of the field part, okay. Stator is the stationary part, rotor is the rotating part of the machine. This is the drive end, the moving end or the moving point of the machine, and here this is the non-drive end or the fixed part of the machine, which is fixed over the foundation, over the base by using nuts and bolts. See, here is the way out for cooling air flow, so that it will receive some air which will help the machine to cool itself. We know after the complete operation of this machine, heat will be generated, heat will be produced, and to eliminate, to reduce this heat, fans are also used and cooling air flow setup is there for cooling purpose. Now see, as we have discussed in the diagram, there are two main parts of an induction motor. Number one, stator. Number two is a rotor. So, first we will discuss what do you mean by the stator. Listen students, stator is the word derived from the word static or stationary, which means fixed, not moving. So, as its name indicates or suggests, the stator is a stationary part of the induction motor. Clear? A stator winding is placed in the stator of induction motor and the three-phase supply is given to it. So, always remember, first point is stator is the static or stationary part of the motor. It is placed in the stator of the induction motor. The stator winding is placed in the stator, and to this stator winding supply is given. Okay. As it is a motor, it always needs a supply. Clear? Coming to the next, rotor. The rotor is a rotating part of induction motor. The rotor is connected to the mechanical load through the shaft. Okay? No doubt, rotor is the moving part, is the rotating part, and this rotor is connected to the mechanical load with the help of the shaft placed in the center of the machine. Why it is connected to the mechanical load? What do you mean by mechanical load? Moving load, which can move, which is supposed to be rotate. So, through this shaft, the rotor is connected to the load, which is mechanical in nature, so that after moving of the rotor, this mechanical energy, this mechanical output will help the mechanical load to rotate. Okay. Next, what are the other parts of a three-phase induction motor? Let us discuss one by one. First one is your shaft. The shaft for transmitting the torque to the load. It transmits the torque to the load. Okay. In the last slide also we have discussed. The rotor is connected to the mechanical load through the shaft. So, shaft is the agent which is used for transmitting the torque from the rotor or from the machine, we can say, to the load side. Clear? And remember this, the shaft is made up of steel. Now coming to the next, the bearings for supporting the rotating shaft. Okay. Next, one of the problems with electrical motor is the production of heat during its rotation. We have already been told, okay, during its operation, during its whole principle of working, heat is generated, heat is produced. So, in order to overcome this problem of production of heat, we need a fan for cooling. Otherwise, it may lead to damage of the windings, either the field or the armature. Clear? So, हम लोग use करते हैं ये fan so that there will be reduction of heat. There will be elimination of the heat which is being produced during the whole rotation or operation inside the induction motor. Next,